I'm Ms. Bukhari, and today we're going to see how we're going to calculate the arc length of a circle. What we'll start with is a bit of revision of the terms that we need to use in our arc length calculations. First of all, what is an arc of a circle? An arc is any connected part on the circle's circumference. So if you take a circle with center O and you have 2 points on the circumference A and B, then this part is the arc AB. And we know that these two are the radii of the circle. Alright, the second term that's used in the formula is the angle at the center of the circle. What that means is it's the angle that subtends our arc AB, whose vertex is at the center of the circle. So let's call that theta. So the angle at the center for arc AB is theta. We know also that this arc is proportional to the angle at the center which subtends it. So we know that the total angle at the center of this circle is 360 degrees. So we can work out the length of the arc given by L. We say L is the proportion of this angle over the total angle of the circle, which is theta over 360 degrees times its circumference, which is 2 pi r. And that's the formula. The other term that we need to know about is sector and how that fits into our arc length calculations. A sector is a plane in the center which is bounded by the two radii and the arc between A and B. So if we can picture that as the circle with that bit cut out, that is called the sector, and its measurements are R, and that's the arc length L, and that's our theta here that we've just learned. Finding the arc length. Draw a diagram and put all the information in our question and give the answer correct to 2 decimal places. So the first thing we do is we draw a diagram and put all the information in our question on the diagram. And you know what we say? The only thing better than a diagram is a bigger diagram. So let's draw that. And our radius is 1.5 centimeters, so that's 1.5, and this is also 1.5. And the angle at the center is 48 degrees. And let's call this arc length L. So theta is 48 degrees. R is 1.5 centimeters. The formula for L, the arc length, is L equals to theta over 360 times 2 pi r. So we substitute the values into the formula and we get 48 over 360 times 2 times pi times 1.5. and we plug in the values into our calculators, and the answer that we get is 1.257. The question asks us to give the answer correct to 2 decimal places, so that becomes 1.26 correct to 2 decimal places, and we can just say the length of the arc is 1.26 centimeters. 2. What is the length of the arc at the equator if an angle of 65 degrees is subtended at the Earth's center? Now assume that the Earth's radius is 6,400 kilometers, and I want the answer nearest to a kilometer. So now is the time to pause. Alright, I'm sure you guys had a lot of fun working this one out. We'll work it out together now. So let's draw the diagram. So we've got the Earth with its north and south pole. And we know that equator is an imaginary line, an imaginary center, right at the center of the Earth. So this is the center, and that's our equator, which is actually a circle. And we're saying that we need to find the length of the arc, which is subtended at the center by an angle of 65 degrees. So 65 degrees here. And these are the 2 points on the equator. And this is the length that we need to find. So let's just take that out and draw it as our sector. So that's center of the Earth. And the angle at the center is 65 degrees. And this is our radius, which is 6,400 on both sides. And this is the length we're trying to find, the arc length. So we'll use our formula, which is L equals to theta over 360 times 2 pi r, which becomes 65 over 360 times 2 times pi times 6,400, which works out to be around 7,260.57. Now the question asks us to give the answer to the nearest kilometer. So the answer to the nearest kilometer is 7,261. So I hope all of you got that answer. If not, that's fine. We'll do some more practice questions next time, and I'm sure it'll become more clear to you. So I hope you've enjoyed this video today. Thank you very much.